All right, in this next lesson here we're going to look at is just analyzing differential equations. And there's no real new content here. It's just practicing, making sure, again, we understand a differential equation. It's literally an equation of the derivative. So even without finding its solution, so to speak, we can still learn a lot about the expression that it's modeling. So look at a few examples just to get your brain juices flowing. So we'll consider this differential equation, dy dx equals y squared plus 1 times x plus 3. And we know that y equals f of x is the solution passing through the point negative 3, 5. We don't know yet how to find that solution, but we just know it exists. So what do we know about the behavior of f of x on the y-axis? So on the y-axis, we know that x is 0. That's literally the definition of y-axis. So if you plug in x equals 0, we get dy dx is 3 times y squared plus 1. And we notice that this is always positive. So y squared plus 1 is always positive, times 3 is always positive. So no matter where I am on the y-axis, my slope is always positive, so y equals f of x is increasing wherever I am on the y-axis. At negative 3, 5, does f of x have a relative max, relative min, or neither? So first I'll plug that into my slope. If you plug in negative 3, 5, you get that dy dx is 26 times 0, which is 0. So it's a critical point at negative 3, 5. We just need to figure out if it's a max or min, or it could still be a neither. And what we're going to do here is the second derivative test. So as you recall, if the second derivative is positive, you have a minimum. And just draw something concave down. If your second derivative is negative, you have a max. So then you want to recall the previous stuff you've been learning. And you take the second derivative. So you take the derivative of your derivative. And you got to do the product rule here. So it's y squared plus 1 times derivative of x plus 3 is 1. Plus derivative of y squared is 2y dy dx. Remember to chain that. Times x plus 3. And we can plug in, the point is negative 3, 5. And we already found that dy dx was 0. So you can plug those all in. So you get 5 squared plus 1 times 1 plus, well, this is 0, so I don't care about anything else. So you get 26. So my second derivative is 26, which is positive. So it's concave up, which means I have a minimum at the point negative 3, 5. Okay. So now you have some problems here where you're going to try and basically just work with the differential equations. Remembering differential equation, literally telling you about the derivative. So try out number 1, I'd recommend. Hit pause on me now, try out number 1, and then hit play and then repeat with number 2. Hit pause and then hit play when you're ready. But please try these before listening to me. All right, consider all solutions provided to the provided differential equation. On the y-axis, for what values are the curves increasing, and for what values are the curves decreasing? So y-axis, x is 0. So dy dx equals 2 to the 0 minus y cubed minus 9. So I get 1 minus y cubed minus 9. So you get negative 8 minus y cubed. I want to know when the curves are increasing and decreasing. So basically I need to know first when this equals 0, and this equals 0 at negative 2. And then I need to figure out before negative 2, after negative 2, slopes are positive or negative. And let's try after negative 2. I'm going to plug in 0, and I get negative 8. So when y is greater than negative 2, negative 8 is negative, so the curves are decreasing. And I'll just confirm, I'll pick a number to less than negative 2. I'll look at negative 3. So you get negative 8 minus negative 3 cubed. So it becomes negative 8 plus 3 cubed. Negative 8 plus 27 is 19, which is certainly positive. So my curve is increasing. And in quadrant 2, the curve is monotonic. So basically it just means it's either non-increasing or non-decreasing. So it's just going in one direction. It's either increasing or decreasing. And this quadrant is y increasing or decreasing. So quadrant 2, y is, x is negative, y is positive. So I get 2 to a negative number. So 2 to a negative number. Minus y cubed minus 9. 2 to a negative number. Well, 2 to the 0 is 1. So 2 to a negative number is less than 1. So I have a number less than 1. Minus y is positive, so y cubed is positive. Minus 1, minus 9. So you have a number less than 1 minus 9, so this becomes negative 8 minus a positive. So negative 8 minus a positive means you're getting even smaller. So negative 8 minus 5 is negative. Negative 8 minus 10 is negative. Negative 8 minus any positive number is surely negative. So y is decreasing. All right, now we're going to try a new set here. So we're going to go through number 2. Again, please try it on your own and then hit play when you are ready. So we have this given differential equation, and f of x goes through this point. So f of x is a solution that goes to this point, and g of x is a solution that goes through this point. Approximate f of 4.2 using a tangent line to f at x equals 4. So tangent line, you need slope and point. So the point is given, it's 4, negative 5. And we just need the slope, so dy dx at 4, negative 5. Where dy dx gives you the slope. So if you plug in 4 for x, you get 4 squared minus 4. And if you plug in negative 5 for y, you get negative 5 plus 3 squared. So you get 16 minus 4 is 12 over negative 2 squared is 4. So you get a slope of 3. So that's my tangent line at 4. I'm going to approximate f of 4.2. And we're going to plug in 4.2 for x. So you get 0.2, 0.6 minus 5 is negative 4.4. B, at what x values, if any, does f have a horizontal tangent line? So you have a horizontal tangent line when your derivative is 0. So to set a fraction equal to 0, you set the numerator to 0. You get x equals plus or minus 2. Well, how do we figure out if it's a max, min, or neither? So you can do first or second derivative test. First derivative test is hard because y is also changing. So I'm just going to look at my second derivative here. So I'll do the quotient rule. So you get y plus 3 squared times x squared minus 4 is 2x minus x squared minus 4 times the derivative of that is 2 y plus 3 times y prime all over y plus 3 squared. And I'm not going to clean that, but I'm rather going to plug in. So at x equals 2, so I get y. I don't know what y is though. So we'll see if that matters. So I get y plus 3 squared times 4 minus all of this. Remember, we set y prime equal to 0. So that's all 0. I have a y plus 3 squared. And it doesn't matter what y is. Y could be anything. And this quantity is going to be positive. Remember, y plus 3 squared is positive. And same thing in that denominator. Y plus 3 squared is positive times 4 positive. So this is going to be greater than 0. So it's a rel min. And then we'll do the same thing here. We'll plug in negative 2. So you get y plus 3 squared times negative 4. Minus again. Negative 2 is literally when the derivative is 0. So y prime is 0. So that whole term is 0. Again, same logic. Y plus 3 squared is positive, but times a negative is negative. Over a positive is going to be negative. So it's concave down, so that's a rel max. All right, C, we want to find g double prime of negative 3. All right, so I did find my second derivative here in part B. I'll use that to my advantage. So I need first g prime of -3 I'm going to need. So g goes to the point -3, -1. So to find g prime, you plug into the derivative. So you have x squared minus 4. So you have -3 squared, sorry, minus 1. Oh, I was right, minus 4. All over y plus 3, so y is -1. -1 plus 3 squared. So you get 9 minus 4, you get 5 over 4. So g prime of -3 is 5/4. And so that's y prime, and x I know is -3, and y I know goes to point -3, -1. Y is -1. So I can plug in now. So I have y plus 3, so I get -1 plus 3 is 2 squared times 2x will be -6 minus x squared. That's 9 minus 4 times 2 times y plus 3 is -1 plus 3 is 2 times y prime is 5/4 all over y plus 3, which is 2 squared. So I get 4 times -6, I get -24 minus 5 times 2 times 2 is 4 times 5/4 all over 2 squared is 4. So I get -24 minus 25 all over 4. I get -49 over 4. And then lastly, in D, we're going to evaluate this limit. So lim as x approaches 2, f of 2x plus 5 over g of -x minus 1 plus 2 over x. So first step, as always, we'll plug in. So I need f of 4 plus 5. F of 4 is -5 plus 5 is 0. And I need g of -3, which is -1, plus 2 over 2 is 1, so I get 0. So remember, don't say equals 0 over 0. You're going to show that it approaches 0 over 0. And now we invoke L'Hopital's rule. So then you take the derivative, so you get 2f prime of 2x over -g prime of -x minus 1 minus 2 over x squared. And as x approaches 2, so you get 2f prime of 4 over -g prime of -3 minus 2 over 4, or minus 1/2. So I gotta find f prime of 4. So we actually did that in A. If you want to redo it, you can, but 4, -5, you plug into here to get the slope, and it was 3. So I get 2 times 3. Should I write that here? So I get 2 times 3 over -g prime and -3. So we got that here. -g prime and -3 is -5/4 minus 1/2. Again, you're under no obligation to clean this, but if you want, so it's 6 over -5/4 minus 2/4. So it's 6 over -7/4, which becomes -24 over 7. So there we have it. There's some stuff we can do with differential equations. These are kind of like free response prep. But recognizing that these differential equations have value and they share us information, even if we're not able to, quote unquote, find their solutions yet. Keyword there being yet. With the next lesson, that's not for you all, but with this next lesson, we're going to start talking about how to find solutions to these differential equations. Alrighty, y'all. Take care.